Friends, let's learn electric field due to infinitely charged plane sheet. For this, we require an infinite plane sheet. Let us have an infinite plane sheet. This is a small part of that plane sheet having positively charged plane sheets. On this plane sheet, let us have a Gaussian cylinder. So this is Gaussian cylinder. Let us draw this Gaussian cylinder. So from this sheet points to left hand side, let the distance is r, and on RHS side, our right hand side, the distance is also r. So you have three surfaces as you considered: surface 1, surface 2 and surface 3. This is a charge sheet, so you have sigma is equals to q upon s, where s is the surface area of this sheet's small part, which is circular. Now in this first surface, electric field is in outward direction, and here this you take small surface area, so small surface is also ds. On this surface number 2, electric field is along this direction, and here you have taken the small surface, so it is ds, angle is 90 degree. On third surface, let us take a small surface, so electric field is along this direction and ds is in the same direction, so theta is equal to 0 degree. So we have taken these sheets. Now we are using Gauss's law. So according to Gauss's law, flux phi is equals to close integration E dot ds, which is equals to q upon epsilon naught. As you are saying that there are three 1, 2 and 3 surface area. One is, this is a circular surface area, so it is circle. This is the curved surface area, and this is again the circular, that is circle here. So when you open this, it will be open into 3 part. So let's open it into 3 part. So the electric flux phi is equals to integration part 1 E dot ds plus integration E dot ds surface 2 plus integration E dot ds surface 3, which is equals to q upon epsilon naught. Now in the first surface, you have the angle is theta is equal to 0 degree. So right here E ds cos 0 degree is the first surface. In the second surface, you have E ds cos 90 degree. In the third surface, you have integration E ds cos, this is 0 degree, third surface here, which is equals to q upon epsilon naught. Now cos 0 is equals to 1, so you have E integration ds first surface, cos 90 is 0, so it is 0, cos 0 is again 1, so you have third surface, E take it out E, so ds is here, which will equals to q upon epsilon naught. Now it will be ds will be s here plus E into s, because you are seeing that integration of first surface and third surface will be s is written here. So you have q upon epsilon naught, so you get 2es is equals to q upon epsilon naught. As we know that sigma is equals to q by s, that is said to be surface charge density. You know that sigma is equals to q by s, surface charge density. So from here q is equals to sigma into s. So therefore you can write 2es here is equals to sigma s upon epsilon naught. So this s will be cancelled out. So electric field E equals to sigma upon 2 epsilon naught. This means that the value of electric field does not depend on r. Thus, you can say electric field E is independent pendant of r. This means that this is a constant, only depends on sigma. Now when you draw the graph variation of E versus R, then you have E this side and R this side. As you know, electric field does not depend on R, it is constant. So if the electric field is at this point, with changing R, E does not changes. So E will be, this line will be parallel to the base, that is R axis, R line. So this is E is equals to sigma upon 2 epsilon naught. Now let us have a numerical based on this topic. It is a very nice numerical, important numerical, many times come in competitive examinations and board level examination. The numerical is, I am giving you two charge sheet. This is plus sigma sheet, positive sheets. This is minus sigma sheet, negative sheets, where sigma magnitude is given to you, which is value is 17 into 10 to the power minus 22 coulomb per meter square. So you have to determine electric field on this first region, electric field on this second region, electric field on this third region. You have to find electric field in these three regions. To find the electric field in these three regions, let this plate is said to be plate P and this plate is said to be plate Q. We all know that from positive charge electric field moves outward. So due to this plate, electric field is EP direction outward. Electric field is EP direction outward at second region. In the same way, electric field is EP direction outward in the third region. And you also know electric field due to negative charge is inward. So for this negative charge, you have EQ, electric field direction is inward. This is EQ, direction is inward. This is EQ, direction is inward. Now we have plotted about the directions of electric field on the diagram. Now we have to find electric field on surface 1. So part number A, electric field on surface 1 is equals to electric field due to this P plus electric field due to this Q on surface 1. We know that the value of electric field E equals to sigma upon 2 epsilon naught. This is the formula. So here we will write this is sigma upon 2 epsilon naught, and you are saying that this arrow is towards negative x-axis. So you write minus I cap here plus sigma upon 2 epsilon naught EQ towards positive x-axis. So write here plus I cap here. So this is 0. This means that electric field in region 1 is 0. Now what about region second? Electric field for region second. This is again EP plus EQ, which is equals to sigma upon 2 epsilon naught, and direction is towards positive x-axis. So write here I cap. Sigma upon 2 epsilon naught, direction of this EQ is towards positive x-axis. So write here I cap. These two will add it up, which give you sigma upon epsilon naught I cap. So we have to solve it because we know the value of sigma is given here. So this can be solved by a simple method. First you multiply numerator and denominator by 4 pi. So you have 1 by 4 pi epsilon naught into 4 pi into sigma I cap. Here we are multiplying by 1 by 4 pi by numerator and denominator because you know that 1 by 4 pi epsilon naught is 9 into 10 to the power 9. So its value is 9 into 10 to the power 9. This is 4, this is 3.14, and the value of sigma is 17 into 10 to the power minus 22. So we are going to multiply it. So here you have 9 into 4, 36 into 3.14 into 1717. So it comes to be 1921.68, 10 to the power. Here the power is minus 22 and here it is 9. So minus 22 plus 9 is equals to minus 20. Here 22 minus 9 is equals to minus 13. So you have minus 13 here. This can be written as, put the decimal point at this point. So it is 1.92168 10 to the power minus 10. And the unit for electric field is Newton per Coulomb. So you have Newton per Coulomb. So this can be rounded also, and you get electric field E2 is equals to, this is 1.9 into 10 to the power minus 10 Newton per Coulomb, and direction is towards positive x-axis. So the direction is towards I cap. Now C part, you have to find electric field on the third part. So for third part, we will proceed in the same manner, that electric field, this part is EP and EQ, their vector sum. So it is EP plus EQ that side. What is EP? Sigma upon 2 epsilon naught, and direction of EP is towards positive x-axis. So write here I cap. Sigma by 2 epsilon naught, direction of EQ is towards negative x-axis. So write minus I cap. Again this will be cancel out 0. Thus you have find that if you take two equal and opposite plates, then electric field on the left side of the plate and electric field on the right side of the plate is 0, but electric field between the plate exists. In the same way, if you take another question in which these are of same polarity, then what will happen? Then in that situation, electric field, draw the electric field in that situation. So in this situation, both are plus plate having same charged density. Then you have electric field line moving outside from the charged plus plate. So for this side you have E due to this P moving outside. This is E, Q, this is also moving outside. Here you have E, P moving outside. Here you have E, P moving outside. Now for second plate Q, here you have E, Q moving outside. Here you have E, Q moving outside. This is the outside. Now you are saying that in the first region, E region 1, electric field both are having the same direction. So you have sigma by 2 epsilon naught plus sigma by 2 epsilon naught, which is equals to sigma by epsilon naught, and which is equals to 1.9 10 to the power minus 10 Newton per Coulomb. In the same way, for second part, you have E, second part, you have sigma by 2 epsilon naught at this part. This is a positive x-axis I cap. Here we have to write minus I cap, here minus I cap. So it is minus I cap direction. So in this case, this is at this place EP is towards positive x-axis and this is towards negative x-axis. So sigma by 2 epsilon naught minus I cap, which is 0. For C part, you have E third is equals to sigma by 2 epsilon naught. Both are of positive x-axis. So you have I cap, sigma by 2 epsilon naught I cap, sigma by epsilon naught I cap, and value of sigma by epsilon naught is already calculated, 1.9 10 to the power minus 10 Newton per Coulomb towards I cap. Thus you have seen that if both the plate are of same polarity, then electric field exists on number first. There will be electric field on this side, there will be electric field on this side, but no electric field is between the plate. So if two plates are of same polarity, then between the plate electric field is 0, outside the plate electric field is not 0. If two plates are of different polarity, then outside the plates electric field is 0 and between the plate electric field is not 0. Thus you are learning and enjoying physics. So do like and share and subscribe my channel. Thank you.